Okay, this one is a great question, I think. We've got a diagram, quadrilateral ABCD, where AB is 2 centimeters, and then angle ABC, ACD, and DAB are right angles, and they're indicated on the diagram. Let E be the point on DA, such that CE is perpendicular to DA. Not quite sure they haven't labeled this on the diagram already, but it's going to be the line coming directly down. Prove that the triangles ABC and DEC are similar. So that is this red triangle, and oh, sorry, I didn't actually label E, did I? And this green triangle. Now, there's two ways to prove similarity, and that is for a triangle, that is, to show that the sides are in the same ratio, like the same scale factor going from one to the other, or by showing that all the angles are the same, like i.e. one is an enlargement of the other one. Now, we only have one side, so it's going to be the angle route we need to go with. We can immediately see I've got a right angle here because we were told that CE is perpendicular. So maybe you should just justify this. So CED equals 90 degrees since CE perpendicular to DA. Now I'm going to call this angle X. I want to show all the angles are the same. I don't know what they are, but let's give it a symbol. That means that this is 90 minus X. Do I need to write all this down? I think it's only a 2-mark question. Like, as long as I make it clear on the diagram what I'm doing, I think that's okay. Now this is clearly 90 degrees, so this is X. This will be 90 degrees, and this will be 90 minus X. Might as well add that on. Right, now onto the green triangle. Okay, I've got another right angle here. Okay, so this is also 90 minus X. And then this is X. Okay, so, I'm not going to write any more there, but basically I've shown that triangle ABC has the same angles as triangle CDE. Therefore, they are similar. Okay, good. We're then given that the area of the quadrilateral is 6 centimeters squared and asked to find all possible values for the perimeter of the quadrilateral. Remember, we've just proven that two of the triangles are similar. And I should just make this, draw this line in again. Okay, now it might be worth just drawing these triangles side by side. So I've got A, C, B, right angle, and this is 2. And then this is E. I'm gonna imagine I've like rotated this one round. So it's be easier to compare. This is going to be E, C, and D. And this is quite crucial because this length is going to be 2 as well, because these two lines are parallel. We've got a trapezium, and therefore this length is 2. So we just need to think about the scale factor to go from here to here. And maybe I say that the scale factor is that I just times by y, which would mean that this length is 2y, and this length is then 2 over y. Right, I can label these on my actual full-on diagram now, so I just need to think about this carefully. Um, I've got that this length here is going to be 2y, and then we've just worked out that this length is 2 over y, and this is also going to be 2 over y. And area is going to equal, I can just find the area of this rectangle, which is going to be 2 times 2 over y, and then I can find the area of this triangle, which is going to be a half base times height, so a half times 2y times 2. The half and the 2 cancel, and we're going to get 4 over y plus 2y. And don't forget, we were told in the question that the area was equal to 6. I'm going to multiply through by y. 4 plus 2y squared is equal to 6y. This is actually known as a hidden, kind of as a hidden quadratic. There are more complicated hidden quadratics, but yeah, when I times through by y, I get my quadratic. 2y squared minus 6y plus 4 is equal to 0. And there's a common factor of 2, so I can just divide through by 2. Okay, and we're going to get two solutions to this. Y minus 1, y minus 2 is equal to 0. So y is going to equal 1 or 2. Now I could have, to be fair, I could have worked out the perimeter in terms of y. I didn't actually do that. No, I'm not going to. I'm just going to take each case at a time. So let's look at the case when y is equal to 1. Then I get 2 and 2 here, and 2 here, and also 2 here. So that means this height is also 2, so I can use Pythagoras' theorem. 2 squared plus 2 squared, I'm going to get root 8 or 2 root 2 is the hypotenuse. Okay, that's a right angle. And therefore the perimeter, I just need to add these up. 8 plus 2 root 2. Or when y is 2, same kind of diagram. But this time y is equal to 2, so how does that affect things? This is actually going to be 1, and this is going to be 4. So I'm going to do 2 squared plus 4 squared, that's 20, square root of 20, which is actually 2 root 5. It's always good to simplify thirds. If you leave it as root 20, that should be okay, but it's good to simplify. And then we add it up, we're going to get 3, 4, we're going to get 8 again, but 2 root 5, so slightly larger perimeter. And that's it. Quite enjoyed that. I hope you did as well. Nice. Proving similarity, calculating the area, getting a quadratic, solving and calculating the perimeter.